Okay. So what I was saying, let's suppose we have this type of data points. Okay, and we have created a few centroid. Just for example, let's suppose we have this centroid. Here is the one centroid, here is the one centroid. Okay, and we are going to allocate the pointers to the each centroid. Let's suppose these are all our pointer, we are going to make it at this centroid, and these are the all pointer we are going to make it. Sorry, this intersection should not happen. Should map to this centroid. Now let's suppose further iteration we found this point should be more closer to this centroid. So if it is a higher inertia, in that case, this point, 1 minute. So if it is a higher inertia data points, then in that case, what will happen? This point will never move to the another centroid. So that's what I was trying to say. If it is a higher inertia, then this clustering K-mean cluster will never walk there at that place. Okay. So let me clear this diagram. Next, hold on. Why it is okay. No, okay, I'll use the whiteboard then in that case. Okay. Third stage is that once all the pointers, all the points are assigned to clusters, recompute the centroid. Centroid. Recompute the centroids. Okay. So this is the third stage which we are going to do in a while. And fourth stage is what? Repeat the step number 2 and 3 until the locations of the centroid stop changing. Okay, and the cluster allocation of the points cluster allocation of the points become constant. Cool. This is the like we are going to follow typically. And now let me show you with the Python means these are the point I'm going to introduce with the help of the Python code. And you don't need to worry we have to write this much of code to implement the clustering. No, it's just for understanding purpose what I have written. I will introduce with the Python code, and then later on we will use the Python package, which will sklearn package, which will do all the sort of things directly at the backend. Okay. So first of all, we are going to import some packages. So what are the packages we have to import? First of all, let me make inline-II. Inline in the sense of all the images, whatever images I'm going to show, all the images will show display in the console. So for that, we are going to make pylab inline. This is the magic function. Whatever things is coming with the percentage, that is called magic function. So whatever images are coming, those images will display on the console. Next, I'm going to import from pylab, import stray. Stray means all the library I'm going to import. Import, I'm going to import random, some random library. Random means we have to initialize some data point randomly because we don't have the actual data point right away. So I'm going to import random from import random as pyrandom. So you can give any name. It's kind of aliasing. Okay, so you can give any name. Then what we are going to import? We are going to import from scipy dot spatial distance, spatial dot distance, and we are going to import c distance. Why? Because to calculate a distance, you can use the Hamilton distance, okay, Manhattan distance, whatever distance, but scipy is already providing that function to calculate the distance between the pointers. Now what we are trying to do, we are going to set image color at the background. So for that, we are going to use the matplotlib. Matplotlib. This is not a magic function actually. Matplotlib.rc, and here I'm going to give the name image and comma cmap color map. You can give any color map. Even you can give white or gray. I'm going to give here gray. You can give anything. Now what we are going to do, we are going to import one more library which is called collection library. What it does, let me show you. Collections import counter. So to count that, let me import and then I will show you what we are trying to do. Okay. So these are the packages we have imported. Now what we have to do, consider a collection of the points that are sampled from the different densities. And in this case, normal densities with same covariance but different mean. So what we are trying to do, we are trying to collect some sample from the data points population and do these sample having the different variations. Means what I'm trying to say here, just try to understand. So let's suppose, let me show you whiteboard or Scrabble. Sorry. All right, for this one. Let's understand this part. So I was saying we are going to collect the sample from the different data points or different population. As we are collecting the sample from the different population, so the variance of these all sample will be different, right? So what we are trying to do, we are going to collect the data equal to r underscore. I'm going to create a random data something. Okay, you don't need to worry. So in future you will get this data means somewhere like you will get this data from the CSV or database something. So you don't need to worry. So here I'm going to initialize random number n means number and the shape of 1000 row and 2 column. So I'm going to create 1000 row 2 column and array size I'm going to give plus array, and here I'm going to give 70 cross 30. Let me show you what it does. Okay, actually. So this is fine and okay, cool. So so this is fine, and here I can make a connection. So let me copy paste these things. Okay, so this is fine. And here I am going to just make a difference. First, let me write that and I will explain that code. Don't worry. And no need to remember this code. Even though you are not going to use this logic, just it is just for make you understand the clustering techniques, how it works. Then what we can do, we can create a data equal to data, and here I am going to write py random. Okay, py random is not. Py random spelling is. Acha, sorry. Yeah. So now let me show you. So can you see this? Okay, let me check this save. So what happened? This 1000, 1000, 1000 become 3000 and 2 row. So 3000 karke, you just understand this is the one sample, this is the another sample, this is the third sample. And now we are going to combine all the three sample and making the different data set all together. Did you understand what we did? Just follow this graph and we have a different data set and we are collecting some sample, 1000, 1000 sample from the each sample and we are combining this. That's all. Okay. So now let multiplied with 10. So 10 is basically to make a different values. If you are going to make, it might be possible that random number might be both are same. So what we are trying to do, we are trying to add different numbers to all the pointers, so that the value will be different. Okay. So now what we are going to do, we are going to plot a scatter plot of this data. So what we are going to do, I'm going to make a figure size. The figure size 10 cross 10, you can increase or decrease, it's on you. Now I'm going to plot scatter plot, and here I'm going to give the data from starting till end, comma, row wise it will. So see, this section is row wise and this section is column. So zeroth column, I'm only considering the zeroth column. And here similarly for column, this is for row, and this same thing I'm going to make for column. So how we can make for the column data? Again, complete row, but column will be first, second column. And I'm going to make this dotted line P plus. You can change this. And let me show you. See, this is the data point. Can you see this? This three data set, three data sample. This is the first sample, second sample, and third sample. And each cluster is completely different, we can see, right? So we have to create a cluster on top of it. Are you making my sense what I'm trying to do here? We just plotted this, whatever data we have prepared, and we just try to display these things on a graph so that we can visualize this portion, right? So we have a three data cluster, cluster 1, cluster 2, cluster. Even this we are assuming from the eye. Let's assume by the machine, the machine is able to, make a cluster, segregation of this cluster now. And we can clearly see, that's what we added a different number on this randomly initialized number, so that different cluster will get clear, so that we can easily understand what the machine is understanding with this data point. Okay. So see, with this data point, what we understood, mixture density arises, right? In both the unsupervised learning and supervised learning. In both the cases, they commonly represent the problem structure. Like in supervised, we have a column has been given, means output target column has already given, but in supervised, we don't have the target. If this input we are giving, what will be the output? Here is the completely unsupervised use case. Okay. So now let's create a what next point is what? So see, just read down this statement. First, randomly assign the K center. Okay, that's first point we have to do. So far, we have prepared the data. Now we are going to randomly assigning some K center. Okay, and calculate the distance of all the points from all the K center and allocate the point to the cluster based on the sorted distance. And the model inertia in this is the mean square distance between the each instance and the closest centroid. And the goal is to have model with the lower inertia. So very simple. We are going to assign K cluster. K value can be anything 2, 3, 4, 5, 6, whatever you want, and then calculate the distance of the point, each point from the K centroid, and allocate those points to those centroid. Okay, and based on the distance, shortest distance. So those are the things we have to do. Okay, so I'm trying to do these things manually. So see, right now I'm doing all those things. Each line of code I'm writing here, but again I'm saying these things can be done from the scalar library. You don't need to worry about it. Okay, so now we are going to initialize the centroid. Okay, so centroid. Okay, now question is where you will initialize the centroid. So you can initialize the centroid at a different position. You can initialize here, you can initialize here, you can initialize here. It's on you, right? I am going to initialize randomly position. See, here is the position is also given, right? So let's suppose you have to initialize centroid here, somewhere here, just for example. So what is the value of y at this point is around 15 or 16, and x the value is what? Is something like what I can say, like 10, right? So you can do that. It's on you. So I'm going to initialize centroid at different position. So I'm going to write here protos. You can give any name, centroid also you can give. Array. Two-dimensional array. We are going to give the different position. You can play with this position. Okay, it's on you. So I have prepared 4 centroid. 1, 2, 3, 4. Yes, 4 centroid, and we are going to just initialize the centroid. So here, what we are trying to do, initialize centroid. Okay, nice, very nice. Now, so starting we are just making a copy of it, so that it will. So what we are trying to see, this position will get changed, right? If you can read this statement, calculate the distance, and once this point is assigned to the cluster, recompute the distance and repeat the 2, 3 steps. So this value will get changed, right? So that's what I'm just trying to make a copy of it. So we can see where we initialize the centroid and at final where it is going to reach. Okay. So for that purpose, we are going to make a protos dot copy. Okay. So this is our starting point. Now I'm going to make a figure size. Again, same figure size I can make 10, 10 based on your window size. And then we are going to make a plot, scatter plot. And here I'm going to make a data, same position. So we are just again plotting this plot. So all the rows, comma, only 0th column. Similarly, all the rows and first column, all the rows, first column, all the rows, comma, first column. And then how it will be. See, this value can change. Can you see this? Each point is getting represented by the plus symbol. So this B plus is indicating the symbol type. You can play with these pointers as well. So that's the thing. B plus. Now this is the plot. Now on top of this plot, I have to plot my centroid, right? So similarly, I'm going to make a plot, and here, very simple, protos. And here I'm going to make all the rows, comma, 0th position, comma, protos. This is the protos point. All the protos we have defined here, comma, protos. And here I'm going to make all the rows, comma, first column, and comma, again, I'm going to make a different shape of this centroid. So I'm going to make R0. You can, again, you can play with this arrow and comma mark size is 10. You can, if you are going to make a mark size bigger, the bigger size will be. Let me show you that. Mark size is equal to, sorry, marker size is equal to 10. So let me show you, and now just observe this point. Can you see this? 4 centroid has been created at different position. 1, 2, 3, 4, right? And if I will increase this marker size, the size of this dot will get increased. Can you see this? Right? It is getting increased. So better to have a smaller number. So this okay, right? So first point we done, right? Can you see this first point? Randomly assign the K centroid. We did it. Now, second point, we have to calculate the distance of the all the points from the K center and allocate the point to the cluster based on the shortage distance. This point we have to do, right? So first pointed has been done. Any question in this?
I have one question.
Yes, please.
We have 3 clusters, right?
We have 3 clusters, but centroid we can give anything, right? Let machine has to decide.
Okay.
Yeah. Okay. So see, you God has given you eyes so that you can see that how many clusters are there, right? But let's suppose think about that. If I'll give you the textual or CSV file, will you able to make your decision how many clusters are there?
No.
Right? So let's think in that book way. You have a eye. That's what I showed you means how many cluster can we make, but because of God has, will you do these things in production with your eyes? Machine has to take a decision, right? Correct. So thing is, 1 minute, let me check cell type down. And so I'm going to make some statement here. Obviously those centers are wrong, right? We know. So we have to correct it. But let's keep going. Because I can directly assign the centroid at their position, right? By seeing the coordinate, and I can assign these things. But why I have to do? If I have to do by seeing the data, then what the machine will do, right? So what the goal is here. So now we compute. Now we compute the assignment of the data points to prototypes and array closest. This also is so wrong, but we are going to be using it anyway. Okay, good. So let's do these things now. We have to do the second point of, we have to calculate the distance. And so for distance, we have imported one library, right? If you remember, we have imported this library, cdist. So cdist library we'll use to calculate the distance between the centroid and all the pointers, right? So first of all, let's calculate the distance then. So calculate again, we are going to make a figure size equal to 10, 10. And here I'm going to calculate distance equal to cdist. This is the library, and here with whom we have to calculate, between which pointers we have to calculate the distance between the protos and the data points, right? So protos comma data. So it will calculate the distance, right? So let me show you. So see, these are the distance between the protos and data point. Okay, nice. So four pointers are there. So this is the first centroid ka distance with respect to first centroid, distance with respect to second centroid, distance with respect to third centroid, and distance with respect to fourth centroid. Any question till now? No question. Any question? No question. Now what we are going to do, we are going to calculate the closest distance, right? So for that, what we are going to do, so here closest is equal to our minimum, not max, our minimum. This is again Python package. It's not a like third party library like cdist or something. So that's what we have not imported. Okay, this is the R minimum. And here, what minimum we have to calculate? Distance, right? So distance, comma, axis 0 means row wise. Axis is equal to 0. So what we are trying to do, let me show you control Z. So this is the closest points. And now what we are trying to do, we are trying to allocate the closest point to the centroid. For I in range of length of photos, and what we are trying to plot data closest equal to I, comma 0, comma then again. So we are going to allocate these pointers to that closest centroid. That's only we are trying to do with this line. So data, and again, so each pointers we are trying to do. So data, comma closest equal to I, comma 1. So 0th one and 1 column. First 0th column and first column. And then what pointers means we are going to make a different color to whatever. Let's suppose first protos may allocated five data points. I'll make a different first one color. Second protos may second color. Third proto third color. Different color we are going to make. So how we can make a different color? Simple, very simple. So just allocate these pointers, comma C plus. You can make anything, comma G plus, comma B plus, comma Y plus. Here I'm going to make all the pointers, and then a simple plot. I'm going to make a plot, and here I'm going to make photos. All the all the rows and first column. 0th column, similar to comma, photos, all the rows and first column. That's the thing. And now I will make a different color, like R0, R2, comma, marker size equal to 10. So let me do these things and let's see. Can you see this? What happened? So here we have given the different color. So see this centroid, for this centroid, these are the pointers, which is closer. And for this centroid, I think this is the only this much is the pointers at the closer. Then I think this centroid, these are the pointers at the closer. And for this centroid, these and these are the closer. Right? So we have created a different color for the different centroid. Okay. So now what we are going to do, okay, so let's read once again this statement, what we have to do. So very simple, randomly assign the case center, that is done. Calculate the distance of all the points from all the case centers and allocate the points to the cluster based on the shortest distance. That also we did it, right? Here we did it, right? So we did it. Now, okay, now what we are trying to do. So now we are going to shift this centroid, right? We have to shift this centroid. Okay, read the third point. Let me read the third point. So third point is saying the model inertia, the mean square distance between the each instance and the closest centroid, and the goal is to have model with the lower inertia. And once all the pointer has been assigned to the cluster, recompute the centroid. So what we have to do, we have to recompute the centroid. We are going to recompute again the centroid, and again we will calculate a distance. So it's very simple. So now what we are trying to do, so we are going to change the centroid. So what we are going to do, we are going to make a variable called history, and we already have a starting point, right? We have done it. Now I'm going to do again protos dot copy. This is done. Now what we are trying to do, simple. So we are going to arrange means this protos at a different position. So and then we will append these values of new values of protos in the history, so that we will have a history of complete protos from where we shifted, right? So here I'm going to write a for I in range of then protos I colon I comma colon 20 range. So just I'm shifting randomly like data. So we have to do this step how much time? Until unless the shifting of data, shifting of centroid will get constant. Means even if we are shifting somewhere, the distance between the pointers will get stable. It gets constant. Then we can say this is our finest point. Okay. So closest data is equal to data closest equal to 1 comma axis equal to 0. Now this new protos point, this is the new protos, right? So we have to append this protos, new protos. So history dot append, because it's a list, and here I'm going to copy new protos values. Protos dot copy. So that's fine, and this is okay. Now now again same thing we have to do. Same thing what we have to do, we have to plot this centroid at this position. So we already have written this logic, right? So let me do these things. Yes, this is the protos, and this is the copy and marker says 5. That's okay. Now same thing we are going to do here as well once again. So we have to again we have to plot a scatter plot of data point, and we have to set our centroid on the data point, and then again we have to calculate a distance, and based on that we have to allocate the cluster data points, right? So now again, yes.
In this fifth line, you have written history dot append. Just the protos is allowed. Dot copy is not.
Sorry.
Dot copy is not. Protos dot copy value.
So, I'm not getting your question. Can you rephrase the question? Hello.
Here in fifth line, history dot append, you have given protos dot copy.
Yes.
But that is only protos line.
So see, new protos value, whatever protos is there, that proto you can write a protos as well, you can write a copy as well. So copy means it's like a deep copy. Sorry, solo copy. So solo copy in the sense of if you are changing something, let me show you that part, why I'm doing these things. Because see, have you read the solo copy and deep copy concept?
Yeah.
हाँ, तो solo copy, deep copy में क्या होता है? Let's suppose if I'm going to write x is equal to 10, and if I'm writing y is equal to 10, okay? So just observe this point. So, and sorry, y is equal to x. And now, if I will update the value of x ka value 10, sorry, x ka value by 1, something. Statement is 1 equal to 1. So I have just added one more value. So y automatically y value will get changed. That is called deep copy. Now, if I'm going to make a solo copy like this, then protos ka value will get updated, then this history value will never get updated. That's the agenda. That's what I wrote like this. Did you understand what I did?
Yeah.
Got it? Because protos value will keep on changing, right?
Yeah.
But that's a good question you asked. Fixed size. And here I'm going to 10 content. Data. Same 0 के लिए, comma. Bear with me, like, see, if you really want to know how algorithm works, then this is the approach. But if you really want to know just what the algorithm does, then I can complete within a one line of code. It's very simple. Calling the SQL library and feed the data, transform the data, and get the evaluation. That's all. This is called clustering. But I wanted to show you the feeling of actual understanding the coding, actual understanding the algorithm, actually. So tomorrow, if you go for the interview, you don't need to show this coding, but at least you should know what the algorithm does at the back, right? But feel free, you guys can give me the feedback if you really want this kind of way of teaching, then it's okay. Otherwise, I will directly jump into the actual way of doing the coding. Like I can call the library and I can do that. That is also a way I can do that. It will save my time as well. But I wanted to show you this part. History array, and I'm going to make an array of history. I'm going to make for range of then of suppose same thing we are going to do. Now this time, what I will do, I will shift my centroid. This is the centroid, right? I will shift some position. So here, plot. First, I will plot history H array. So we plotted this. Now let me show you this graph. Can you see this? What happened here? So see, this pointers has been moved from some instance. Let me complete this code and then I can show you that part. Okay, so this has been done. Now similarly, sorry, I will make a different color so that I can show you the visibility and markers I am going to make it 10. Font size 10. That's it. Now also I have to plot new plots, new photos, right? So photos. So this is the history we'll plot, and now I will plot the photos as well. So photos, and here I'm going to meet it. 0, row, comma. Now we use a different color this time. Persons. That's okay. We plot this and now see. in series, what happened? So initially red color was there. So initially the data point was somewhere here and here somewhere, right? Now new position of data point, it seems like all are pointing at the same position. Is it right?
New one is black, right?
New one is black, yes. New one is black. Earlier at this position. Sorry, new one is the red one and older one is the black one. So this is correct. Let me show you, see what I did a mistake here. So I made a figure size this and data this one plus black one. So then what we are trying to do, we are going to create a history array. So we have created a history array and then we are going to what happened? Just a minute. And then we are going to make a range of plot and plot history array. And here I'm going to make a history array. That is correct, true only. And this is the H array. For size is 10, this is 2. This is correct, absolutely correct. Somehow this all pointer is getting lie at the same point. Okay, let's see. So let's see what happened here. Somehow we shifted the protos at some instant, but what happened after the shifting this protos, all the pointers is getting lie at the same point. So no need to worry. No need to worry. What we can do, we can calculate once again the distance. Okay. So to calculate the distance, what I can do, I will write the same logic. What was the logic to calculate the distance? Yeah, this was the logic, right? So I will do the same logic here as well. So now I'm going to range 1,000 times. I'm going to iterate over it, and I'm going to do this thing. And this is the new protos. And now what we are going to do, we are going to plot these things and let it to be C. Oh no, no. This is weird. Hold on, hold on, hold on. Just a minute. Let me see what mistake I did. I'm not able to visualize these things. One minute. We don't do. One second. Let me run this 1 second. And then I'll see. have got the distance, and that is the distance we are going to allocate to the center line. Because there is nothing to do. And here we are going to do the history. This is it. And next is what we are trying to do. I don't think so. There is a big mistake here. So now it is getting visualized. What mistake it was? एक minute, huh? It's the same only. So this is the code back previous one. Let's see what difference meeting here. Are you guys able to see any difference between these two lines, these two sections? Not actually, and then these
No.
here. Anyways, so you can see this shifting is happening right from here to black is the previous one and red is the newer one. So we are going to shift this plot photos to the different position, and now we will calculate the distance once again, and we will see. Okay. And now if you'll see, can you see this what happened here? So earlier this was this position, second point this, and third, fourth, at fourth iteration, this reach at the center position. Similarly, this point from here to there, there to there, there to the movement you can see. Similarly, for this position from here to here, it got moved at the center of this position, right? So we understood these pointers, right? We understood the movement of the pointers, and it got automatically shifted. It got automatically shifted at the center position. So right now we assume the 4 clusters are there. So that's another challenge of this problem statement. Understanding how many cluster you can make, that is the bigger challenge. So for that we will learn the different algorithm, how you can justify how many cluster is needed for your defining your data pointers, right? So that is the different challenge. But as of now, first of all, you are going to assume the problem. What is the drawback in this algorithm K-mean cluster? The algorithm, the drawback and limitation of this K-mean cluster, you have to assume that how many cluster it is, right? And then based on the how many cluster it is, you are going to allocate that centroid at the center position. But what will happen? Your assumption is wrong, right? So in that case, this algorithm will never fit. So for that, another algorithm came into the picture, which is called K-mean plus clustering. Okay, that I will discuss about that. So in that, that algorithm will automatically decide how many cluster it will be. Okay, so again, I'm saying these things you no need to do by coding. If you are thinking, means in real time, you have to write like this logic. No, there is a K-mean ke liye separate package we have. That package you can call and it will do internally. Okay, so let me write my final conclusion here. As you can see, the final location of the prototypes or
told, when we are going to decide this is the final, we need to calculate the distance again. Right?
It got calculated, and you can see it here, right? I wrote a for logic, and 1,000 times I iterate. Where I wrote? Here, sorry. This 1,000 times I iterate, and it got automatically calculated distance, and it fixed that point at that position where the distance is not getting varied. Okay, so that's a logic is already written in the for loop. So if you go to this definition, let me show you this definition what I have written. So the K-mean cluster algorithm is saying what? First of all, randomly assign the K centers to the data point. K center, it's your assumption. 400, 500 is on you. Then calculate the distance of the point from the K center to each point, each data point, and then allocate the point to the centroid based on the shortest distance. This is the second step of the K-mean algorithm. Then what we are trying to do, once the all pointers has been assigned to the cluster, recompute the centroid. That we did it. right? And then we are going to set the centroid at some instance. And then again, we are going to compute the distance between the pointers and the centroid. We are doing this stage until unless the distance between the centroid and the pointers is not getting stable, right? So that's the part we did it. So that, and again, this much of coding you don't need to write whenever you are going to deal with the k-mean cluster. It gets done by the k-mean cluster package, which is coming under the sklearn. But whenever you will go for an interview, you should explain this part in that way. So how it is getting shaped from here to there, then interview will get to know, you know the algorithm actually, right? So as you can see, the final location of the protos center red color. What is that? Red color, right? Red in color are nicely in the center, in the centers of the class, of the classes. And the algorithm doesn't give us exactly the centers. Clusters, because there are three clusters, but but we populated, we postulated, sorry, we postulated, we populated, we can write, populated 4 cluster centers. Okay. So did you understood what I written here? So we initially we assume 4 cluster. That's what it is, not completely seems like a making a cluster, right? But this is the drawback of this k-means. You can mention this point. Now, okay, now what we can do, we are going to allocate these pointers. The final graph, and you can see. So for this cluster, this is the central. This cluster, this is the center. In this cluster, 2 clusters, because we understood that 4 clusters. That's what it clearly made it cluster, right? For these pointers. But to be honest, we can make it in 1 cluster. That is also right. Okay, right. So we understood, right? Any question? No question. So now, if there is no question, let me write one more point here. So the diagram above shows the step-by-step implementation of the k-mean cluster. K-mean algorithm. Okay, very good. As we saw earlier, we need to provide, the value of k, right, before hand. But the question is how, right? How to get a good value. That's a question, right? Good value of k, right? This was your question, right? There is a 3 cluster I can see, and you mentioned 4. So that's like how you can understand what is the optimal value of k, right? So an optimum value of k is obtained by what? obtain using another algorithm called using the elbow method. So using the elbow method. So let me show you elbow method. Okay, how this elbow method does. So पहले तो elbow method का graph understand करते हैं. Like we try to understand what is the elbow method. So so what how the elbow method works according to the Wikipedia. This method based on the relationship between within cluster, sum of squared distance or inertia means what we are trying to do within cluster, inside of cluster, we are going to calculate the sum of squared distance and number of cluster. Let's suppose 4 cluster is there. How much sum of squared distance is coming? Similarly, 3 cluster, how many sum of square of distance is coming? And we are going to calculate, we are plotting this graph. Let me show you this graph now, how we are going to understand this. Just a minute. Let me take a screenshot of this graph so that I can. Observe this point. So can you see this? What we are trying to do, let's suppose at the very beginning, we understood 4 cluster will be there. So with the 4 cluster, we are going to calculate a sum of square distance and we are going to plot a pointers. Okay. 1 cluster, how many sum of square distance is coming? 2 cluster, what is the sum of square distance is coming? 3 cluster, what is the sum of square distance is coming? And then we are going to draw this line like this. And at any point, this point is getting break like this. See, from here to here, it is coming smooth line. And here it is getting bent directly. So this pointer is going to decide this is the optimal number of cluster. Did you understand what I'm trying to say? Yeah. So that part we are going to do with these things. Let me show you with the elbow graph. So these are the things we are going to do. So don't worry, these are the things is already provided in your what? In your note drive. So you guys can download it, feel free and do play with this. Now, these are the things that we have shown you the actual implementation. Now I will show you with the package. Directly import, I will import the package and do that things. Okay. So, so for these, what I have to do, I have to get the data point, right? Store this data point near to these, and then I will import some packages. Let me import these packages. This is the packages. Now I'll read this data point. Mall customers data point. This is the mall customer data point, and you can see the data set. This is the mall customer ID. Forget about the customer ID because each customer will have the unique customer ID. Then gender, age, annual income, and spending score. I think this is self-explanatory, all the features. Yes. Gender, you know. Age, you know. Annual income, you know. Are we providing this information in the mall? I don't think so. I never. But I don't know how these guys are getting to know. Maybe from the PAN detail they are getting know. But yeah. And spending score that can be easily gettable. Like how much you are spending, like on the Pi or Reliance Digital. With that, they are going to understand what is your spending score. These are the things. So we have a 200 row and 5 column. That's fine. Pretty much good. Now what we are trying to do. In this case, what we are trying to do, we are trying to get only what? 2 features, annual income and spending score. And based on that, we are going to create a cluster. Forget about the gender, age, and customer ID, right? Are you making my sense? What I'm trying to do? So we have captured only 2 pointers: annual income and spending score. Okay.
Why we took only this?
So you can calculate these pointers as well. Then what you have to do the label encoding for this, because it's a string type of data. Age is again, I just wanted to make this problem very simple so that I can cluster it. Did you understood? You can, so okay, I'm giving one assignment. Let me give you the assignment. Create a cluster by removing this customer ID, because customer ID is not going to make any sense. And do the label encoding of this gender and then create a cluster. Did you understand what you have to do?
Yeah.
Yeah. It's simple, right? Now I'm going to see. I'm not going to write that first logic once again. I'm just importing sklearn cluster import k-means. Did you understood? And this k-means function will do all those things at the back end. At the back end, it wrote the same logic whatever I have written here. Okay. Then what we are trying to do? We are trying to plot a elbow curve. So how we can plot a elbow curve? Simple. I'm going to calculate the sum of square of within the cluster sum of square. So this is, I am create an array of within cluster sum of square, and then I am going to create a center. And here, see what I did it here. Can you see this? I have written the k-mean plus plus. Logic is k-mean plus. Now k-means is not going to use anymore, to be honest. K-mean plus plus is the advanced format of k-mean clustering. Okay. So here I have initiated a random state. I have created these things, and oh, what happened? Non-terminal split. Where I'm doing split. This is a very common problem I am facing from the long time. Why it is, I don't know. Last time also we were facing this problem, right? Object has no attribute to split. At which line it is coming? 6 k-mean fit. X. Acha, it's capital X, right? The capital X only.
Null values.
I don't think so. There is any null value. Let me see. Is an A. Then dot sum. There is no null value. Okay, null value. Yeah, null value is fine. Is there any string value data? Okay, let me see the data types as well. X dot B types. Okay, this is the object type of data. Okay, okay. Let me make it by integer. I'll check x dot x dot x is not working. Object is still it is object. It's an object. But here it is showing integer, right? Yeah, it is integer. Okay, that's fine. It is integer. That's fine. Become integer. Now let me see this. It is window 32. It seems like some platform dependent. Okay, can you guys try at your end this notebook once? Please try. I'm uploading this once just now. Please try it. Maybe some platform dependency or something. Let me upload this in your drive and do let me know. I will have to fix it because I'm facing this problem in the different classes as well. Like notes. Yours is 5th July, right? Not July.
No, second.
Yeah. So I will upload inside of day 29 only. Okay. And I will upload this cluster and data points. These two things I'm uploading. Please download it and run it in your system. Just run it quickly and then do let me know. If you guys are able to run, then I have to see. This is the Anaconda problem, I think. I just updated my Anaconda. Afterwards only I'm facing this problem because these same slides I was using from the last 6 months. I can do one more thing. I can show you my MacBook. 1 minute, huh? Just bear with me. Meanwhile, you guys can try that. No, so,
Same error I'm also getting.
you are also getting. Okay, let me see in my MacBook. Just a minute. I'm checking in my MacBook. Just a minute. You are not getting this error.
Yes.
And you are not, you are in Mac or which operating
No,
system?
no, I'm using same
A Windows.
Windows. Yeah.
Weird.
Can I show that?
Yeah, if you could, I don't know like what is the problem, but yeah, If in your case it is working, then I can fix it in my system. Can you please share your screen? It will be super helpful. Hey, it is working in my system as well. Like I'm using Mac and it's working at my end. Okay.
Now, if I did second time, it's working in my system.
Okay. Let me see 1 second. I'm trying as many times. This is showing the same error. But yeah. Okay, fine. If it is working in your case, let me share my Mac instance and then I can explain, start explaining. Just a minute, bear with me. Okay. Let me share my screen. Okay, are you guys able to see my screen, right? Yeah, it is working here. Weird, but anyways, that's fine. So you can see, I just plotted this graph between. Okay. Is it audible now? Yeah. One minute, I have to. If it is audible, I have to use this mic only because otherwise recording will be problem, right? Cool. So yes, if it is audible, let me stop sharing this screen and then past it. Yeah. So yeah, with this graph, you can see what we did. We created a number of clusters randomly, 2, 4, and 6, 8, whatever it is. And then we are going to calculate the within cluster sum of square distance. And then we are going to plot this graph. And we found this graph is getting bent between these 4 and 6. So probably the good number of clusters should be between 4 and 6. It can be 5, right? But it should not be in fraction, right? 4.5 never would getting possible, right? So it should be between 4 and 6. So number will be 5. So that is the optimal number of clusters. Now what to do? Very simple. Now whatever things we did it.
We have two time points. Why you take next one?
So this you are saying, right?
Yeah, we have.
So you have to consider those points. Afterwards, it's getting completely smooth. See, from here it is coming down, then again it is going up, right? But this point, after this point, is not going up. It is going completely smooth at a downward direction. That is the optimal number of clusters. Did you understand what I'm trying to say here?
Yeah.
Yeah. So we understood the optimal number. Now the challenging part has gone, right? So what will be the optimal number of clusters? That part we overcome, right? So now, we understood the what is the optimal number of clusters. That part we have discussed. Now next point is remove one from this because it's not needed. So see, next is we are going to create a k-mean object. K-mean object. And here I'm going to create a k-mean algorithm. K-means. And here I'm going to create a number of cluster n underscore cluster. So if you can see these parameters, what are the different parameters are there? You see number of cluster. By default, it is taking the number of cluster, what, 8. So if you are not defining any number of cluster, by default, it will be considered 8 cluster. And by default, it is initializing the algorithm is k-mean plus plus, okay? And then max tire to tolerance, verbose is basically just because whatever things is getting done at the back end, it will display at the console. So that reason we are going to use the verbose. And these are the different parameter. Definition is very good definition, and documentation they have given so that you can use these things in future whenever you want. Um, that's the thing. So here I'm going to use the number of cluster is what, 4. You can try 4, 5, 6, whatever you wanted to do. You can try it out. It's on you. But as of now, we know how much cluster it is. 5, right? So we can use the 5 number of cluster, and then init. If you're not mentioning these things, by default, it will use what? K-mean plus plus, right? K-mean plus plus. K-means plus plus. Okay. And then this is just to reusability. Like, let's suppose I am using right now in my system the number of cluster 4, and in that case, whatever point will be allocated to the each cluster, the same point will be allocated in your system as well. So for that reason, we are going to initialize the random step. It can be any number. It's on you. So we have created this, and now, so with this k-mean, so with this k-mean, what we are going to do, k-mean, and I'm going to predict, and sorry, not predict, it should be fit and transform. Because first we have to train the model. Here I'm going to do. So this is our y predicted value. This is our y predicted value. Next, what is to do? I'm going to write y print. So these are the pointers to the each these things. Okay. So we understood this part. Now next is what? So I'm going to predict something with this model. So we have a model, right? Y mean. So what I'm trying to do, I'm going to write k mean dot predict, and here I'm going to pass array dot array as array, and here I'm going to pass 2 pointers because we have 2-dimensional input, and here I'm going to do k mean dot predict, and so what happens syntax error. Okay, my bad. This 4 videos. And you can see it is lying under which cluster? 4th cluster. If you are passing 3, 3, it is lying under the 4th cluster. So it's very simple. Just we imported sklearn k-mean cluster package, and as soon as we are importing the k-mean cluster package, it is getting done all those things, right? We don't need to do we don't need to show the Python import and Python all this writing the logic what we did on the here, like on the top side. It's just a 1 line of code, as I mentioned. Means in future you don't need to write these things. You have to just import this backend. That things is done. So we solve 2 problems. Number 1, unstructured, unsupervised problem. How we can train the unsupervised problem through the cluster. And second point, what will be the optimal number of cluster using the elbow method? That 2 things we have discussed and we have solved it. Now the question is, as it is the unsupervised machine learning, you don't have the actual label data. Now, how you can compare whether your output, whatever output is coming, is it right or wrong, right? So for that reason, we are going to actually I'm talking about the evaluation. What kind of evaluation metrics you can use to evaluate the unsupervised machine learning problem? Did you understand what I'm trying to say here? right? So in case of classification, we have seen the F1 score, right? And confusion matrix, accuracy, right? These are the things we have seen. True and true, false positive, true negative, false negative. These things we have discussed. Similarly, in linear regression, we have talked about R square matrix, adjusted R square matrix. These are the two metrics we have discussed. Now we are going to talk about unsupervised में कैसे we can evaluate our model, right? So this is the agenda. We'll take it forward from here tomorrow, and we will start the evaluation of unsupervised machine learning because this will take time. Because there is a Jaccard coefficient, RMSSS, and RMS. There is a different kind of metrics. It is we have to discuss, and this is a very popular. To be honest, this was my first question in year of 2019. I think 19 half or 20, which I couldn't answer this question. Frankly, I'm speaking about it, and afterwards, I just added these things in my slide. The evaluation of initially, I was not aware about at all. Like, is it there any way to evaluate the unsupervised machine learning? I was not aware about that. Even if you ask many researchers, data scientists, like who having the 4 5 years of experience, they might not know. Even I'm talking about this OpenAI Chat GPT. Whatever response is coming, how you can evaluate? That's a very important part, right? Now the problem statement got changed. Building a model, anyone can do. Yeah. So we are almost done. We are going to be. So building a model is also an easy thing. Now evaluating a model is very smarter techniques, right? So that part we'll see tomorrow. Yeah. So hope you guys understood. We'll discuss tomorrow and we'll see all those things tomorrow.
Dash.
Yeah.
Yes, I have some doubts. Not having.
Yes, please. You never texted me and I didn't ask.
No, I am trying something. Means I was way back.
Yeah, please.
I'm seeing old videos. Means that about evaluation, you have playlist, right?
Yes.
In that there once means that was random. You can check that one.
Random in the sense I'm not
Random in the sense first two in the first score and you covered first two correct, and third video was there at fifth video.
Okay. We'll arrange this sequence. Thank you. We'll arrange this.
And actually we are working on this idea that is TB treatment plan.
Okay.
So I have some doubts. Means we'll get this particular from the.
Yeah. I'm listening you. Yeah, please carry on.
Okay, I'll show that UI that is ETQ explained.
Let me stop recording.
Okay.